Welcome to a new episode in my Weidmüller Automation Controller series. And up until now, we've looked at how the automation controller works in general. And then in the past couple of episodes, we looked into what you can do in Node-RED, how you generally use the Node-RED, how you can use the dashboard to build UI. But so far we focused on how the Node-RED communicates with the actual hardware. But what we want to look at today is how your Node-RED instance or your automation controller is going to communicate to the outside world. And actually, there is an awful lot of possibilities within Node-RED, and I won't be able to cover every possible communication form that is available in Node-RED, not to mention with all the additional nodes that you can install. So I'm going to just focus on some basic communication forms. Let's assuming that you need to send data to different servers or you need to share data between automation controllers. First of all, I'm going to show you how you can create a server-side request which is actually going to reside on the Node-RED instance and something that you can call from an external server. So you can use the built-in Node-RED itself in order to host an HTTP API, and we are going to just take a very simple example of that. Also, I'm going to show how you can use the very same HTTP request to serve a file which is stored on the automation controller. So let's say we have a CSV file or we have an image file that we store on the automation controller, and then an external client, for example an internet browser, would be able to display that or for example download that information from the server. And once we have done that, we are going to go into the actual machine-to-machine communication. So first of all, we are going to take a TCP example, how you can set up a TCP socket connection between two devices. What I'm going to use here is I do have my own Node-RED instance. So my Node-RED, which is running on a small Raspberry Pi, is going to talk to the automation controller and send data back and forth. Next, we are going to look at how the automation controller itself can make an HTTP request. And I've taken a very simple example. There is a service which is called the openweathermap.com. You can easily register and get an API, and you can get weather forecasts from there. And finally, we look at another use of the TCP socket connection. But instead of a direct TCP port connection, we are just going to use Websockets. And again, I'm going to show you how you can pass information between two devices using Websockets. So the first example I want to show you is how you can create an HTTP request which actually runs on the Node-RED instance, so on the automation controller. And to show that, what I have created, I have this URL. And if I call this URL from an external computer, which is now my laptop, then of course I need to log in. Then what I can get is I can get the actual pressure value that is coming from the pressure sensor that we used in the previous exercises as well. So I can create an HTTP endpoint that any device can use, and in that endpoint I can serve data or basically whatever I want from my Node-RED instance. And in order to make this work, I had to go back and modify my previous flow just a little bit. If I go back to the dashboard, if you remember, this was the IO data in node that we used to get the pressure sensor. And then after I strip the object from the all the values and I just keep the actual value, I've created this change node, and in this change node I have saved this data in the global variable, so global.pressure. And again, just to repeat that, you can create these global variables. So I created one for pressure, and I've also created one for saving the out2 global variable. So now these values are available in the global, and this is accessible in any of my flows. So in the communication, I can just easily get these values that are stored in the global. So what I need to do is, if I just, sorry, not MQTT, HTTP. So I have two nodes that I'm going to use here. One is the HTTP in. As it says, it creates an HTTP endpoint. And then you have an HTTP response. So these always needs to be in pair. As you can see, I have an in, and then it goes into some sort of logic, and then it should end up in the HTTP response. And in the HTTP in, you specify what is the URL that we want to use. So /global. and it says that the URL will be relative to /red. And if you see what I have used in the request, so this is the IP of the automation controller, /red is the Node-RED instance, /global, it's what we have specified here in the HTTP in. And I just use the regular HTTP convention, how I can pass query parameters in the URL. So question mark parameter equals value. So I said variable equals pressure. So I can here say that whether I want the pressure or whether I want the out2 value. And now it's 1. And if I flip the out2 value and if I refresh, then I get 1. So when this URL gets called, then the request details are coming off from this node. You can see here in the debug, and you can see what the payload is and what the variable. And then just like with any HTTP request, you can have request parameters, so query parameters. In the query object, I have a variable attribute which equals out, and that's basically it. So the variable is my attribute and the value is out. So I can use that to tell whether I want to return the pressure, a global variable, or the out global variable. So the data goes into a switch, and in this switch I just decide whether it's the pressure or the out, and then I just basically retrieve the global variable pressure or out2, I put it into the payload, and I send it back into the HTTP response. And because I just send back a simple value, it appears in the internet browser as a single value. Of course, I could have sent in a web page, or I could have added HTML formatting so it looks a little bit nicer. But if you just want to send some value back that another device can use, I think this is sufficient. And that's it. So this is how you create an endpoint to serve data into external systems. The next example, actually the next two examples, are using the same HTTP in and out, but then serving different data types. As I said in the first example, I just basically sent text back, and my Google Chrome was smart enough to know that this is a simple text, so it just displayed on the screen. But what happens if I want to send something back, which is probably a different format? So I created another HTTP in, which is called getText, and the data comes in and it goes into a node that we haven't used yet, which is the file in node. And here I can specify a file that Node-RED should read. And in here I specify that /run/media/mmc something /test.csv. And that this test.csv is a file that I've copied into the SD card that I've inserted into the automation controller. And this is just a simple CSV text file, so it's a UTF-8 and default encoding. So that's the parameters how Node-RED should read the file. And what this file in Node does, it reads the file and then puts the file content into the message.payload. And because it's a simple text file, I can just send it off to the HTTP response, and that should be it. So if we test it out, again, I just test the URL and you get this response. So this is my CSV file, and actually this is what I have saved in the CSV file. So serving text files over an HTTP endpoint, really, really simple. Next one is an image. This is a slightly bit more complicated. Again, it starts with the HTTP in, where you specify the endpoint, and then it also goes to a file in node where I read a PNG file. The only things I have specified here is I don't want Node-RED to treat it as a text file, so I said that the output should be a single buffer object. The binary file data goes into the payload, and I've also added this change node, which is required so my Google Chrome knows that the response which is coming back, it's not actually like a text file or just a random binary image, but it's actually an image/PNG. And these are the standard HTTP headers that I'm changing. So I'm actually creating an HTTP header, and in the content type, I'm specifying that's an image.png. So if I do get PNG, I get an image back, the Weidmüller logo. Okay, that was simple as well. So what I have done here, I wanted to show you how you can send information from an automation controller to another machine which is also running Node-RED. So this could be another automation controller. Let's say you have an automation controller in a pump and then an automation controller also in a different location, for example in a water tank, and the two needs to communicate to each other, whether the pump should stop once the tank is full, something like that. And if the two are connected over either internet or a local network, then you can just use TCP connection. And for this example, the server is my Node-RED and then the client is the automation controller. So let's look at the server side first. And to be honest, it is a fairly simple setup. And here I have created two different examples because what we see here is we have an inject node which is triggering every single second. And in this inject node, first of all, in one instance, I'm just sending the pressure value. So I'm just sending a single value, as you can see, to my server on port 6000. And also in another instance, I am setting the payload into a JSON, which is going to contain two values. So it's going to contain the pressure value, and it's also going to contain the value of the out2 variable. And that's going to be sent. So I'm specifying it as a JSON, and I'm using this JSON node here, which actually converts the JSON into a regular string. So that's getting sent also to the server, but on port 6001. So I'm sending two pieces of information to two different ports at the same time. And on the server side, the only thing that I've configured, let me close these, is I have a TCP in node, which I set to listen on port 6000, and then it expects a stream of strings. And if I turn on the debug, we can see that we are getting the number. So this is the actual pressure value. And of course, because we are receiving the pressure value as a string, all I have done is I'm just converting to a number. So I get a nice number that I can work with later on. So that's, fairly simple. It's just a single node. You have a node which is receiving the value, and on the other side, we are going to see that you have a node which is sending the value in. So if I close this debugger and if I open the other one, that's the one which is receiving a JSON. As you can see, the value comes out from this TCP in node as a string, and I know that that string is actually a valid JSON, so I'm just converting it back to a JavaScript object. So we can see that we are getting a very nice object which has a pressure attribute, and it also has an out2 attribute. And let me scroll to the bottom. You can see it's coming as ones, and if I, for example, switch off the output, then now we are getting zeros. We are getting the data every single second. And on the automation controller side, so I've already mentioned how I'm formatting the data, and once the data is formatted, the only thing I'm doing is I'm sending this into a TCP out node, which is set to connect to, obviously, on the same port of the server. So my own Node-RED instance is running on a server which has this IP, and it is pretty much same on the other TCP out port. So the only difference is that it's using a different port number. And pretty much the only reason I'm using two different ports, because I know that one is going to return a JSON and the other one is going to return just a single value. So I just have to treat the value differently. But if you are just sending JSONs, you can just send in through one single port, and then, well, technically it could be anything, because, for the TCP server and the TCP connection, this is just, numbers that are going through. And this example shows you how you send the data from the automation controller to another Node-RED instance. If the other Node-RED instance also needs to send back to the automation controller, you just basically have to duplicate the flow. Obviously, you also need a TCP in on this side and a TCP out on the other side. But it's as simple as that. In the next use case, I'm going to show you how you can use public APIs to query and actually download information. And for this, I'm also using the HTTP node, but that's not the HTTP in and the response that need to be working together, but you also have a separate HTTP request. So this is a node where your Node-RED is going to go and ask for a URL on a different server. You can even use this to download any home pages. In this example, it is going to be slightly simpler because we are going to use OpenWeatherMap API. And if you go to openweathermap.org, you can create yourself an account. And once you go into that account, then, well, you can select different pricing plans, but there is a free plan which is limited to up to 60 calls per minute. So I think that could be more than sufficient for, you know, some basic use. That then within this API you can get a lot of different weather related data, and I'm going to show you the very basic one, which is going to get the current weather forecast. And here you can see the entire documentation, how you need to call that, and then how the data is going to be returned, what are the different variables, what each of the data mean. So everything is nicely documented here. And the only other thing you need to do is when you go back here into your account, you can also go to API keys and you can generate yourself an API key, which is just going to be a long list of numbers and letters that we are going to use now. And now the only thing we have to use is the HTTP request. I'm just using this inject node to start the whole process. And then we have an HTTP request. And in this HTTP request, we enter the URL that we want to call. So again, this could be a website or anything. In our example, we are going to call the API, the current weather API. And if I open up the full URL, you're going to see that in this URL, we are going to put Q equals the city that we want to get the weather forecast for. You have also the APP ID, which is your API key that I just mentioned previously. And I'm passing another parameter as well, which says units equals metric. So I get these, the weather forecast in metric unit. So for example, the temperature in centigrades, the wind speed in kilometers per hour, or I think it's actually meters per second. So this HTTP request is going to call this API, and it's going to return me on the output node whatever this server has returned. And this OpenWeatherMap API returns the weather forecast in a JSON format, which you can change to other formats, but the default is JSON. So I know that whatever comes out here in the payload is going to be the JSON string that I can convert to a JavaScript object, again using the JSON one, and we can test it out. So if I call the API, now it calls the server, I get the result, and I can see that, for example, you know, this is an object and it has a weather, again, object, which has a 0 object, and it has some values that, for example, at the moment, the weather forecast is clear sky. And if I open this, that the temperature is 19.44 degrees and the humidity is 77%, winds and clouds, and some of the other data that all the API gives me. So just to keep the example simple, what I have done is I've created a bunch of UI text nodes. And here I'm just printing some of this data into the screen. So city, I'm getting it the message.payload.name, which is here. And I'm also getting the temperature, which is the message.payload.main.temp, which is here. And I'm putting degrees centigrade at the end, pretty much doing the same with the humidity. And I'm also getting the current wind speed, which again, you can see it here. So, you know, fairly simple. And I've created a new group for this on our UI. So now I have a current weather group, and it shows me the current weather for my city. And of course, at the moment it's triggered manually, but maybe you can set it up so it runs every hour or maybe every 5 hours. And then once you go into your dashboard, it's always going to show you the current weather forecast for your location. And last but not least, I also wanted to give you an example how you can use Websockets to communicate between different devices or server and clients. And before we do that, I just want to refer back to this network group. And as you can see, we have already used the HTTP in and the response, so these two work together. We have just seen how you can create an HTTP request to a different server. So that was the weather API that we have looked at. Now we are going to look at the WebSocket. Of course, this also has an in and out node, which is really similar to the TCP in and out. So the one is the server component, the out is the client component. It's going to be pretty much the same here as well. So there is a WebSocket in, which is the, let's say, the listener node, and then the WebSocket out, which is the sender node. I also wanted to mention that the same pair is available for UDP as well. And that works exactly the same as TCP, but they are using UDP packets instead of the TCP packets. So it's really up to you whether you want to use TCP or UDP. The reason I choose TCP because I'm guessing if you want to send information over, that information is probably important, so you might want to have the sort of security which comes with the TCP protocol, with the handshake and the acknowledgement. But again, you might just decide to use UDP instead, especially if your network is less reliable anyway and you are just sending data on a regular basis. When losing one of the pockets is not such a big issue. Going back to the WebSocket connection, so the first example is again very simple. Here the automation controller is again the client, so this is sending information to another Node-RED instance. And here I just wanted to show you again some two basic examples. So we are sending a text of hello world, and we are also sending a JSON string where it has a hello attribute and a word value. Very similar to the TCP out node, you have a WebSocket out node that you configure. Well, you just specify the WebSocket endpoints. So ws:// the IP and the port, and then /data. That's the endpoint. And on the server side, I have a WebSocket in node, which is listening on the data path. Of course, I don't have to specify the server address here because, well, that's the server. So the IP is obviously given. And all I have done here is I just sent the data into a payload. So if I send the hello word in, then, well, the hello word comes out on the other end. And of course, I can also send the JSON in, and the JSON comes out on the other end. Of course, I haven't converted this JSON into a JavaScript object, so it still appears as a string, but you can use the same method that I've used here. The only additional piece of code that I have done here is the data that comes out of the WebSocket also goes into this function node, which is basically counting how many seconds or minutes have elapsed since the last message was sent. What is also configured on this node that once this wait time or the time since the last message exceeds, for example, 50 seconds here, then it sending out that value on the output port of this function node. So for example, you can use this to give some sort of alert that the communication has broken between the server and the client, and the server hasn't received data from the client for more than, well, in this case, 1 minute and 30 seconds now, which could be an indication of some sort of network issue, especially if you are expecting this client to be sending data, let's say, every second or every 10 seconds. And of course, for this function node to work properly, you also need an inject node which runs every second, which runs basically the calculation here in this JavaScript code. So it checks every second what was the last time the last message was received. And of course, if I send the new data in, then the timer restarts and I'm no longer getting messages until the 50 seconds mark comes again. And the last example for the WebSocket server is, well, it's more like a little bit of gimmick. I named it as a chat and the chat server. If you have multiple automation controllers dotted around, let's say in a big setup where you have different automation controllers on different sites, then you can use this simple example so that all your different automation controllers send in messages, for example, alerts or simple status messages into your server. So on the server, I've again created another WebSocket in, which is listening on the /chat URL or on the /chat path. And the data that I'm going to be sending in, it's always going to be a JSON. So I'm converting the string into a JSON or a JavaScript object. And I created this very simple function node which collects these messages and it keeps the last 20 messages. And then it also formats these messages into a UI template node. If you remember, this is the UI template node that we use to display the on and off status. And what I'm using now is just to display a list of messages. And as you can see, I've just done some basic HTML formatting, italic, and a line break. And let's look at how it looks like on the client side. Well, it is fairly simple. In this time, I've used the UI form, which we haven't used before. UI form is really, really simple. It just has a text box, so I can type in a message that I want to send. And obviously it has a send and a cancel button. Well, we don't even need a cancel button, to be honest. And I've decided that I'm going to send the data in like this. So the data is going to be, or the payload is going to be an object which has a sender attribute that I've defaulted to AC1, automation controller 1. So that's the name of the device. And then the message is the message that I typed on the UI form. This is what I'm sending into the WebSocket. So again, it's a WebSocket out. The type is set to connect to, and then I specified the WebSocket URL of the server. And then let's see how it looks like on the UI. So I have a group which has this form. I can type in the message, and let's see, this is my message, send. And on the server side, I've also created a very small group. So it says AC1, that's the name of the server, and it says, well, this is my message, and I can send in a new message, and I have the new message here. So again, this list is going to keep the last 20 messages, and then it would automatically delete the oldest one. But you know, really, really simple example, but in most cases, especially when you are monitoring a large network, this is a very basic function that you need. You need to monitor messages, especially alerts and warnings that are coming from other servers, and you can just create a very simple WebSocket connections, and then, you know, your automation controllers or your site would be sending in using different IDs, and they, let's say they just send in a simple message which gets pre-formatted and it gets displayed on the screen. Of course, if you're doing it in a production, you would probably want to do it a little bit more complicated than that. Maybe the messages also need to be stored in a file or in a database as well. But I just wanted to keep it really simple just to give you an idea of what you can do with WebSockets. Of course, it doesn't necessarily have to be WebSockets. We have seen how we can transport data using TCP socket connection. I could have done it easily, exactly the same way, using simple TCP connections as well. Probably the other reason why you want to use a WebSocket connection here, because when you specify a WebSocket here on the client side, you can specify a secure WebSocket connection. So if your server is sitting somewhere on the open internet, then Node-RED can use secure communication to send the data securely over to that WebSocket. And I think this is probably something that would be easier to be done instead of using TCP socket connection with some sort of TLS security. And this concludes my Node-RED communication episode. Just like before, I'm going to put the link for these flows into the video description. And this time there is going to be two flows. Obviously there is going to be a client flow. The client flow is the one that I have done on the automation controller, and the server flow is the one that I have done on my private Node-RED instance. But of course, well, it doesn't have to be that way. The server could be the automation controller and the client can be another computer as well. It doesn't really matter. So if you want these examples, look for the links in the video description. But that's all for now. Thanks for watching, and hopefully see you in the next video.